Okay, so we'll get started here. A couple of little things to note. Since the last time we had a Zoom session, the education has changed a bit. We're all at home, and they have announced that diploma exams are optional. So I'm thinking with 30-2, probably no one's going to want to challenge the exam. My 30-1s, a few of them, depending on the program they're going into, may be requested to write it, but I'm kind of thinking that probably none of us are going to write it. And so that gives rise to a question of what I'm going to do about a final exam. And I don't know if I have the power at our school to make that decision, but I'm thinking that since all of you will have had 7 supervised exams by the time you get through my course, that I'm comfortable enough not giving a final exam and just giving your classroom mark as your mark. Okay, I have to make sure that that's okay with admin and the other diploma teachers, because we are trying to, be a little bit consistent. However, some teachers have not had the capability to do as much of the supervised testing as I have, so there may be a little bit different decisions. So just make sure you're watching as this rolls out from your teachers, so that you kind of know what in your class is the ruling. The other thing, and I'm waiting to hear back from my friend Miss Nakaska, some of you might have her for English, she's our ATA rep. The final deadline, I've heard rumblings that my marks are not due at the office when I was originally told, like at the beginning of the semester. I might have a bit of an extension. If that's the case, then you guys will get an extension on January 8th. At the moment, everything is status quo, but I am waiting to talk to her at lunchtime when we're done and see if that is the case. It could be that there's just a secondary deadline for anyone that might need a mark to go up late. Occasionally we have kids in the hospital, or we have circumstances where I have to do a course correction mark, but I'm not sure if that's the date that the other gal that I was talking to alluded to. So a couple of things, probably no final exam, maybe an extension on the due date, but again, not sure. But I just wanted to kind of chat with those things. Okay, well, let's get started on sinusoidal functions, and we'll do a little bit of an introduction. Sinusoidal. Okay, in easy terms, sine functions. Okay. And we do a number of things at the beginning in terms of just getting comfortable with sine functions. And then we get and do quite a lot of graphical work. Okay. So up until this point in your trig math career, you really will only have been exposed to degrees, measuring angles in degrees. Here we're exposed to measuring angles in radians. And so there's a second unit that is given to us to deal with. So I want to show you where it came from and kind of answer the question as to, well, why would we want to know this? And I'm going to do it by talking about a circle for a moment. So if I have a circle, and I'm going to do it with a circle of radius of 1, okay, I'm going to remind you of the circumference formula. That's way back from grade like 9. Circumference equals 2 pi r. Now we also know that one rotation around a circle from here all the way around is also 360 degrees. So a rotation all the way around a circle is also considered to be rotating around 360 degrees. If we replace r with 1, because I happen to have a unit circle, what we call a unit circle here, their circumference reduces to the expression 2 pi. And then we just equate these two, and we say that 360 degrees is equal to 2 pi radians. And I just write as rad. If we divide both sides by 2 to make things a little simpler, the conversion factor is that. Now, whoops, that's supposed to say a D. In 30-2, I do make you guys do a little converting. I know if you were to go ahead to the, the diploma exam, I think they do a little more estimation. So it might be important and useful for you guys to know that in general, as an estimate, 180 degrees is approximately 3 radians, right? You know, pi is 3.14. So we're just trying to do some estimations. You're trying to figure out whether your answer would be even reasonable. 180 degrees is approximately 3 radians. So one of the things that I like to show, and it is maybe a step up from what they want, but I make my students do it because I don't think it's terrible, is to convert from degrees to radians and use this little conversion factor that's in the box. And so this will address the question about 4A on the assignment. So let's just move that over and let's do a little bit of conversion. So convert from degrees to radians. And I'll show you a foolproof way of doing this every single time using ratios. There are other ways to do it, but this is foolproof. And we don't spend a ton of time on this, not like my 3-1s who spend a lot of time on this. Okay, so let's say that I ask us to convert 120 degrees to radians. Here's a really nice, easy way to do it. We don't know the answer in radians, so we just pick a letter, equals to x in radians. And below it, we put the conversion factor that's in the box there. Okay, so see what I did there? 180 degrees goes on this side, pi goes on that side. And then we simply cross multiply. You guys that probably have done some cross multiplying in your days, right? So we get 180 multiplied by x is equal to 120 multiplied by pi. Now we divide by 180. And you don't have to do it in this many steps if you're very confident with your cross multiplication. And we get 120 pi over 180. Now we have to reduce this here. But you guys know your calculator will do that for you. Okay, I don't often teach the calculator, but we might as well know the little shortcuts that I think are appropriate. So if we just go in our calculator and go 120 divided by 180, math, enter, enter, the calculator will reduce that for us. Okay, and I want you to I don't often tell you guys just use the calculator, but you go 120 divided by 180, and then on your calculator, it's the enter button, and then math, enter, enter. Because the math button asks you, do you want to change it back to fractions in lowest terms? So if you do that, you should get 2 over 3, right? And so then we just can write our answer as 2 pi over 3. And that's an exact answer, okay? And that for 4A is asking to convert and leave the pi in there. Now, if we wanted it as a decimal, so if we wanted to, so this is an exact answer. If we wanted it in decimal form, then we would just use our pi button on our calculator. So we would go x equals 2 times 3.14, etc. over 3, and we get a decimal answer. It's not an exact answer, but I will say in 30-2, we're not quite as concerned about exact answers as we are in 30-1. So this would be 18.85 approximately. Okay. All right. So I do stand on ceremony and get you to do a little bit of the pi work. And so we'll mess around going from radians back to degrees. And then we'll move on and flesh out some of the other stuff that you guys asked about. Okay. So next question then is, we want to go back the other way. We want to convert from radians back to degrees. Okay. So I'll give you a radian measure, and we'll do a couple of these. We'll do so let's say the radian measure is pi over 4. This is maybe a teeny, just on kind of the edge of what would be asked in 30-2. We do them exactly the same way as we just did over here. We put pi over 4, whoops, equals to x. And on the bottom, we just have to be careful. The pi has to go on this side and the 180 has to go on this side. So we just reverse If we know that pi and 180 are equal, we just make sure that the radians goes on the one side and the 180 goes on the other side. Okay. Now, do you guys understand that the pi's could cancel on the left-hand side? Oh, I see a little bit of a deer in the headlight. Look, let's not do that then. Let's just cross multiply and do what we did. So we would get this times this equals this times this. So we get pi times x equals 180 times pi over 4. Oops, pi over 4. I should write the 4 right underneath the pi like this. Now we've got pi on each side. Now we can reduce the pi's. Divide both sides by pi. And now just get your calculator out and go 180 divided by 4. And you get 45 degrees. So this method of doing the ratio works every single time as long as you line up the radians on the one side and the degrees on the other. Okay, it works every time. Same process. Don't have to teach you 2 ways of doing it. My 30-1s, I show them a number of ways because they have to engage in it a little bit more than you guys do. So we try to keep it simple. Let's do one more of these where the radians is just given without the pi. So let's say we're trying to convert 2.63 radians. The process is identical. So we put 2.63 equals, and I'm just using the arbitrary letter of x. And then on the bottom, we've got pi, and on this bottom, we've got 180. Now cross multiply again, everything's the same. So we get pi times x equals equals 2.63 times 180 degrees. Divide both sides by pi. 2.63 multiplied by 180 divided by pi. And then you just get your calculator out and work that out using pi as the pi button. Okay, so let's do that. Why don't this time, rather than me doing it before you guys get a chance to tell me, why don't you guys tell me what you get? Just send me a private message for what you get. And then I'll put the answer up. Get you guys a little involved. Okay, so if you put 2.63 multiplied by 180 and then divided by the pi, I didn't tell you where to round off to, I apologize, but we would probably maybe go 1 decimal, 150.7 degrees or 151 degrees, something like that. Okay, all right. So that's how we get started in sinusoidal functions, is understanding that there's this second way of graphing. Now, we need to spend a little bit of time on the graphing calculator before I address the other questions that were asked at the beginning from the assignment. So grab your calculator out. We're going to play around with it both in degrees and radians because this is paramount to being successful in the second part of the module. Okay, so have it ready and let me help you get it set. We're going to work in degrees first of all because probably you're in degrees, and get it set up for you. And then we will redo things in radians. Okay, so first thing, you got to make sure that the mode is in degrees. So just double check when you hit the word mode, let's see the degrees is darkened in. You make sure you're in degree. Okay, now to be able to graph y equals sine x, so we're looking at a sine curve, we have to change the window settings. So good window settings to start with for x are minus 360 plus 360 scale of 90. And for y are like minus 2, 2, and 1. So go into your window settings and go minus 360, 360, 90, and then minus 2, 2, and 1. Get your window settings. Okay, so I can make a better title. To graph in degrees. Number 1, check the mode. Number 2, check the windows. Number 3, go to y equals. So now hit the y equals. Make sure nothing else is there. I got all my 30-1 stuff in there. And you're just going to type in the word sine. So hit the sine button and then X. So again, just so that you guys can double check what we've got, like that. Just sine X, close the bracket. Okay, drum roll then. You should be able to hit the graph button. Drum roll, graph button. And you should get a beautiful sine curve that looks like this. Okay. Okay, so that doesn't look like it's quite, let's double check our window settings to make sure, because you should get this out. Okay, so I'll pause the recording for a minute to talk to you guys to make sure everyone can get that. Okay, so now that we've graphed in degrees and we can label a bunch of stuff, but I'll get to that in a moment. We're going to look at graphing in radians, because you will find more times you'll graph in radians, I think. I'll say that carefully, but I think you're going to graph in radians more than in degrees. Okay, so the first thing you're going to do is you're going to go into the mode and you're going to change to radian mode. So you hit the mode button and go down and you make sure that radian is now darkened. So it looks like that. That's step number 1. See how it's blinking? Okay, then you have to change your window settings. The window settings for radians is about minus 6.28, 6.28, and 1.78. Now, the reason that those numbers come up, it's about minus 2 pi, and pi over 2. So you can put those in as well, either one of those, okay? And I think I'm close to the 1.78. Let me see how good I did there. Oh, 1.57. Let's change that a little bit to be a little closer. 1.57. Okay, and then the y don't change. This is at least something is the same, minus 2, 2, and 1. Then go and regraph y equals sine x. So you probably still have that in your graphing piece. I haven't caught up and changed my window settings, so just a second. Okay, there and there. And of course, you better get the same graph, right? It shouldn't change the shape of the graph. The graph should still be the same. Starts at 0 and 0, goes up, goes down, goes like that. All right. So I'll pause again for a second and make sure that those in class have no problem doing that. Okay, excellent question was asked. The question was, when do we know we're to work in radians and when do we know to work in degrees? If it states in the question which unit to use, obviously that's the unit you use. And if it does not state, we assume radians. So I'll write that on the board. Okay, so we use the given units, or if none are given, we assume radians. And if you're not sure on anything that's, from me, because obviously we're not writing a diploma anymore, just pop me a quick message. I think everything is very clear in my courses, and I've got it all sorted out, but if there's anything, let me know. Okay, we want to pull apart and talk about this sine curve now. Okay, there's a whole bunch of terminology associated with sine curves that we need to be introduced to. So here we go. Hold on to your hat. We need to know what amplitude is. We need to know what midline is. We need to know what period is. We need to know how to find the maximum value. We need to know how to find the minimum value. Let's start there. More things might come of it and more things might not. Okay, the amplitude is how tall the bump is, so to speak. That's not very good terminology, but it's how high it rises. Okay, so it's the distance from the midline. So let's do some color coding here. The midline I'm going to put in green. It's that what cuts the graph apart in half horizontally like this. Okay, so the amplitude is the distance from the midline to the maximum or the midline to the minimum. So I'm going to write that down. And I'm going to have to just pause for a second and plug in my computer. Distance from the midline to the max or midline to the minimum. Okay, the midline is what cuts the, it's right in the very middle horizontally, okay? So it cuts the graph in half horizontally. Now I'm going to move my words down a little bit. So period. The period is how long it takes for one cycle to happen. How long for one cycle to happen. Now, what does one cycle look like? Let me do some color coding. Here's one period. Okay. So generally, a normal period of a trig graph is equal to either 2 pi if it's in radians, or if it's in degrees, it's 360 degrees. So it takes 360 degrees or 2 pi to do that nice cycle. Start at the center, go up, come back down to the center, go down to the minimum, come back up. Okay, that's what the definition of period is. Okay. The maximum is just that, the largest maximum. Oof, having a hard time spelling that. It's how high it is. Now you can find the maximum by going D plus A. Okay, and that's going to become important when we go to analyze things. And the minimum can be found by going D minus A. So if you guys develop your own little formula sheet, on your own little formula sheet, you might want to write those two little formulas. To find the maximum, it's D plus A. To find the minimum, it's D minus A. Okay, and also there's a couple other little formulas that come up. Say we're given just information about the maximum and the minimum, we're asked to go back and find the D and the A value. All right, so to do that, if we think of, say, this question here, where we know that, well, I haven't really noted it, but sorry, it goes to a maximum of 1 and a minimum of -1. If we're looking at this and we're trying to figure out how to figure out the amplitude and the midline from the maximum and minimum, we can do this. For midline, it's maximum plus minimum divided by 2. That's for midline. And for amplitude, it's maximum minus minimum divided by 2. So on this board here, let me just change my color. We have 4 little formulas. Actually, we have one more that I haven't even quite got to yet. We got those 2. We got these guys. And period. I haven't talked about B, but I'm just going to write it. The formula here is 2 pi over B, or 360 over B. So there's another formula. Okay, so there's a whole bunch of information. Now, I'm just going to pause for a minute. I'm going to look at the ones that you guys asked me at the beginning of the Zoom session to see where I kind of morph to next. So just give me a moment. Okay, so this question, we're going to jump from just the information about graphs into a graphing question to see how we can apply some of this stuff. So this is similar to 7C on the assignment. It says the distance from the sun is given by, and I made something sort of similar, 1.4 times sine 0.0214 bracket n minus 173 bracket plus 120, where d is the distance in millions of years and n is the number of days in a year. Okay, something I haven't, it's hard to try to collapse an entire module into like a 40-minute session. One thing we haven't talked about is the general equation for sine curves. So we should probably have that here. And it's y is equal to a sine. And there's two ways to write it. For our class, we normally write it that way. Okay. But sometimes we have this b factored out. We're not going to worry about that too much. This is normally how we worry about it in your class. There are some other things we do. But so the A, the B, the C, the D, they all do different things. Okay. So we will want to flesh that out before we even blast off into this question. And we may not get around to doing too much more than this. If you look back at these 5 things that are circled, you notice that I have D's and A's in here. I don't know if I was super clear that A is amplitude, because A starts with amplitude, and the midline is actually D. I don't think that I was super clear about that. Okay. So when we go over here, we've already talked about the A and the D. A is the amplitude, D is midline. So I'm just going to write those down. That's amplitude. And D is the midline. Now the B value helps us find the period. It's not the period, and I have 30-1s and -2s get that confused. The B helps you find the period, is not the period. It helps find the period. Okay, so again, period is 2 pi over B. And you guys know why I put the 2 pi in there rather than the 360? You notice that this is a question where it did not tell me what units to use. So we were asked a while ago, how do we know? We default to radians. So we're defaulting to radians on this. Okay. And then in here, this is what we call the phase angle. I'm not going to talk about this today. That's just a little bit too much that we don't need to do. And I'm just going to double check your formula sheet. I believe on you guys' formula sheet that the C is minus C. I don't want to leave it with the wrong. But we're really not going to look at the C today. It's a little bit more than we need to be doing in one sitting. No, it's a plus. Okay. All right. I have it right. It's a little bit different. We analyze things a little bit differently in 30-1 as we do to 30-2. So, okay. So let's see what kind of questions we can be asked about this particular question. Okay. And make the questions again, kind of similar to the ones on the assignment, because that's why we're going about doing it. First question. Oops, not fair. How far? How far from the sun are we on, I don't know, June 12th? Considering this is every year. Okay. Now, do you guys know how to find out how many days in each month in case it comes up on a test and I don't allow you to have a calculator in front of, or a calendar in front of you? You guys know how to do this? Yes, yes. Use your, you guys ever seen that? So the top bump, if you start here in January, has 31. Now February is the only one you have to know has 28. March has 31. April has 30. May has 31. June has 30. Come back here. July has 31. September 30. October 31. November 30. December 31. Coolest way of remembering is your fist.
Yeah, the big bumps
right?
are the
big bumps are 31. Okay.
arrows in between.
So we can count this out. So we just put this down. June, I'm just going to start it. Sorry, January, February, March, April, May, and June. So again, just get your fist out. 31. We do have to know that February is the off month. We have 28, 31, 30, 31, and then we're only to June 12th. Add those numbers up, and that tells us what day of the year we're looking for. Okay, so Grab your calculator. I get day 163. Is that what you guys get? Okay, so we're looking for how far we are away from the sun on day 163. Let's put our formula down that we're given. D equals 1.4 sine 0.0214 bracket n minus 173 bracket plus 120. Okay, so this is a day. So again, if I can do some color coding, we put it in here into the n. Be really careful. If you don't have your mode in radians, you will not get the right answer. Okay, so throw this into your calculator and evaluate and go into private with me and tell me what you get. Your calculator, just in case you're not sure, you'll have to do some double bracketing here. So that's how you put in your calculator and then hit enter. Okay, so let's all try that. And then, like I say, send me a message with your answer in it and we'll compare. Okay, so we're back. And so when you throw this all in and you're really cautious about the brackets and that you're in radian mode, geez, I just about said degree mode there, you're going to get 119.7 approximately. I didn't tell you where to round, and that's millions of kilometers. Okay, so that's how you go about and do that.
Well,
okay, so let's do one more question on this one, and then we're going to wrap up because our time's getting a little bit long. Another question that's similar to things asked on the assignment is, what's the period of this cycle? That's the one that I want to do, even though I'm kind of skipping over. So what is the period of this? What is the period of this cycle? Now, I might not have made anything that's going to be too logical, but remember that the formula for period is 2 pi over the b value. So we take the b value, again, I can do some nice color coding here so you can see. B is going to be this guy. So we get our calculator out. Whoops, let's go back to the actual pen. And then we have 2 pi divided by 0.0214. Okay, so let's do that. Just do your calculator, 2 pi divided by 0.0214. And we get 293.6 days. So in this example, it takes 294-ish days for the whole cycle to happen. In real life, probably the answer is going to come up to be closer to 365 days. Why? Because it takes 365 days for us to travel around, right, for a year. So we'll see. So keep that in mind when you're doing the one on the assignment. I think the answer comes out quite close to 365. So we're a little long, so I'm going to wrap up the recording.